Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today we will focus on river delta formation and how sediment deposition creates distinct deltaic landforms over time. A delta forms where a river carrying sediment enters a standing body of water and the flow decelerates enough for particles to settle. The key process is the reduction in flow competence and capacity as velocity falls, causing suspended load and bed load to deposit. To understand morphology and stratigraphy, we divide the delta into three principal subenvironments. The top set is the near horizontal zone at the river mouth. The foreset consists of inclined beds that accumulate as sediment progrades seaward. The perdelta is the deeper, lower energy zone where fine sediment settles farthest offshore. Grain size sorting is important. Coarse bed load like sand and gravel drops out first and contributes to levees and distributary channel beds. Finer silt and clay remain in suspension longer and form prodelta muds. Settling velocity and flocculation in saline water influence how those fines settle. We classify deltas using the dominant physical process at the coast. River-dominated deltas have strong channel networks and lobe building. Wave-dominated deltas are reworked alongshore and become cuspate or smooth. Tide-dominated deltas have extensive tidal channels and elongate sandbars. An instructive example is the Mississippi River Delta. It exhibits repeated lobes switching through avulsion. As one lobe becomes choked with sediment, the river abandons it and establishes a new channel, building a new lobe seaward. This creates a complex stratigraphic record of topset, foreset, and prodelta sequences. By contrast, the Nile Delta has been substantially altered by the Aswan High Dam. With the dam trapping sediment upstream, the delta no longer receives the same supply of sand and silt. As a result, coastal erosion and relative sea level rise cause shoreline retreat and increase subsidence. Another case is the Ganges-Brahmaputra Delta, which receives an enormous sediment load from the Himalayan drainage. High sediment supply combined with significant tidal influence leads to a very dynamic distributary network and rapid delta progradation in some areas. Sediment supply versus accommodation space controls vertical growth. If sediment supply keeps pace with subsidence and sea level rise, the delta builds upward and outward. If supply is insufficient, the delta will drown or retreat. Human activities such as damming river channels or extracting groundwater can alter subsidence rates and reduce sediment flux. Those changes often accelerate delta loss because natural replenishment is interrupted. Process interactions are also critical. Waves can redistribute sediment laterally and smooth delta shorelines. Tides can promote channel bifurcation and maintain wide tidal flats. Storms can episodically transport large volumes of sediment and reshape lobes. On a stratigraphic level, deltas record cycles of avulsion and lobe switching. Each lobe typically shows a transition from coarse fluvial deposits in topsets to dipping foresets, and finally to fine prodelta muds. Geologists use those patterns to interpret past river behavior and sea level history. Predicting delta response requires an integrated view of sediment budget, hydrodynamics, sea level trends, and human impact. Restoration efforts often aim to increase sediment delivery or reduce subsidence to allow natural delta rebuilding. In summary, river delta formation is a balance of sediment supply flow dynamics and coastal processes. Examples like the Mississippi Nile and Ganges-Brahmaputra illustrate how different balances produce distinct delta forms and stratigraphic records. That concludes the overview. In the next session, we will look at quantitative models for predicting progradation rates and how grain size distributions influence foreset geometry.
Listen again to part of a lecture, then answer the question.
When sediment supply falls because of damming or river diversion, the delta can no longer build vertically and begins to subside and retreat.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.